So dictionary, as we know from our daily life, is what we look up and what the value is from the key we look up. For example, we used to look up the words in one language to another and so on. So similarly, in this example, I'm giving a name to ageDictionary. So in this case, what we are creating is a key value pair. That is all about dictionary, creating key value pairs. So in this case, we have 3 key value pairs. So what about the time and space complexity for this? So creating this dictionary is also ben time and also ben space complexity, which means it is linear with the key value pairs, which is n is the key value pairs. So the more key value pairs we have, the longer it takes and the more memory it takes. But what about inserting an element, deleting an element, and searching an element in the dictionary? So now this is where the beauty of this comes. So in these operations, on average, we have constant time, constant space. So this is on average. What about the worst scenario? On the worst scenario, we have linear time and linear space complexity on the worst case. So what do I mean by worst case versus average case and so on? So in order to explain this a little bit better, I think it will be helpful to say what these Python or any other language that you may be working with is doing in the background, right? So when we write a dictionary like this, it is using a hashing function. And let me comment this out. It's using a hashing function in the background. And what does this hashing function do? It is converting the keys to indexes, and then it is storing them in the arrays. So it depends how optimum this hashing function is for us to be able to clearly and precisely say what the time and space complexity is. But with the advanced algorithms and hashing functions these days, more often than not, we are seeing constant time, constant space on average. So that being said, let's go ahead and run this dictionary so that we have Kyle, Rohit, and Lale's ages here. So what are some of the basic operations we can do with this dictionary? We can get the age of Rohit. So for that, we will use .get function. So first we will give what dictionary we are using to get the value of what. So we are using ageDictionary to get the value of Rohit. So age of Rohit is 69. So what are some of the other things we can do? We can change the value of the key. For example, ageDictionary. Let's change the age of Kyle. Okay, so we are gonna give, okay, age of Kyle is now 27. So let's run this and we see now that the age of Kyle is 27. So we can print all the keys for I in ageDictionary. Print I. So let's go ahead and run and we see we printed all the key values. So what if we want to print the values? For that, we have multiple ways. One could be for I in ageDictionary. We can say print ageDictionary, square brackets, I. So we are giving print the values of each and every key that I am visiting, which is I in this case. So we can see that we are printing the values. What could be another way we could have printed these values? Could be for I in ageDictionary that we could have say get the values only, and then we would be visiting those values only. So we could have done it this way. Okay, I made a typo. It should be values, not value. And then we would be creating all the values as seen on the right. So another example we could do, sometimes we need both keys and values. So for that, we could say for key value pair. So as you see, it doesn't matter what I'm giving here. I could be giving any letters, any words, and so on. I like to give K, comma V because it reminds me that I am actually searching for keys and values. And then we are saying age dictionary print. Okay, so we have to do one thing here. We have to give this items. And then we have to say print key value pairs. Let's go ahead and run this. And we see that Kyle 27, Rohit 69, Lale 54. So these are some of the basic operations and some of the basic time and space complexity about hash tables dictionaries.